So here's a homework problem from homework number 15, and this entire homework problem set involves the central limit theorem, which, if just a reminder, tells us that if um, even if a set of data is not normally distributed, if you take groups of that data and find the mean, those means will be normally distributed. And so then you can analyze the data. And in fact, as those groups get bigger, those sample sets, those size n, the size of the groups that you take, gets bigger and bigger and bigger, the more and more normal the curve becomes and the closer and closer into the mean that you get. Okay, but let's take a look here at this problem. It says the capacity of an elevator is 10 people or 1,750 pounds. So you've all gotten elevators before where it says no more than 15 people on this elevator. You do not want to exceed so many pounds. The capacity will be exceeded if 10 people have weights with a mean greater than 175 pounds. So, because if you take that 1750, which is the maximum weight you can hold, and you divide it by 10, a maximum of 10 people, maybe that's all that can fit in the elevator, you're going to end up with a maximum average weight of 175 pounds. It has to average out to that. So if somebody's really heavy, there better be a light person on there to balance that out. So that's the average weight. Suppose people have weights that are normally distributed with a mean of 177 and a standard deviation of 26. Okay, so let's take a look at what that is. And in fact, let's add this first question. Find the probability that a person who's randomly selected, his weight is greater than 175 pounds. So now we're talking about just individual people. So with all of these problems, any problem that's in Chapter 6, we start with our normal distribution curve, because we are told that everything's normally distributed. Okay, and then we are going to go ahead and we're going to label this curve. We always start with our mean. Remember to always, if you go straight to your template, you will always, it'll start to trigger your thinking. So this is our mean, which we are told is 177. It's 177, and what does that mean? Let's define our x. In this case, it's the weights of people in pounds. Okay. All right, and this is our z. That never changes. This is our z-score. And the z is right here at the mean. The z-score is 0. All right, so that's sort of the template. We are told the standard deviation for this problem is a standard deviation of 26 pounds. Jot that down. We'll need that in a minute. All right, and it says find the probability of persons randomly selected. What's the probability they exceed 175 pounds? I'm actually going to change our color because that's now my x. So 175, because mean is 177, I know 175 is below that. I'm going to write this with a dotted line or a different color, however you want to do it. I think it's great if you have some colored pencils. And this is where x is going to equal 175. And we're asked what is the probability it will be greater than 175. So we're talking about all this area here. All right. Okay. So this is a lot of review here, this first problem. We're going to have to find our z-score because we can't find this area under the curve until we find its z-score. So, but what we're trying to do, and I'll write it out over here, we're trying to find the probability that x, some person, is greater than or equal to 175 pounds. Okay. And that is going to equal the probability that z is greater than or equal to what? I'm not sure. You have to figure that out. So we're going to go over to the side. We are going to use the z formula, which should be right at the top of your paper. It tells us that to find a z-score, we take x, which is 175. We subtract the mean, which is 177. And we divide it by the standard deviation, which is 26. If you plug all that into your calculator, you're going to get a z-score. Now my calculator says negative 0.0769, but because we're going to use the z-table, we're going to just carry that out to negative 0.08. Okay, the z-tables only go out to the hundredths place, okay? All right, now I'm going to write that right up here on my table. So it's negative 0.08. So really thinking about what these numbers mean. It means that 175, it's not a whole standard deviation below the mean. In fact, I should have drawn it. It actually should have been drawn in much, much closer to the mean. It's just not even a tenth of a standard deviation away. Okay, so it's very close in. But this is the z-score. It's not the area. What we ultimately have to find is right here, this area under the curve. That is our probability. Probability. Okay, that's our question mark, and that is what this P means. It's saying what is the P stands for probability. The probability that this is probability that X is greater than 175 is equal to the probability that Z is greater than minus 0.08, because I standardize it. Because this is greater than, and my table only ever gives me less than, I'm going to change this to, this is also equal to 1 minus the probability that Z would be less than or equal to negative 0.08. You always want this sentence, the probability of Z, to be less than something before you go to your Z table. Equals 1 minus, and now is when you go to your Z table. Now we've spent a lot of time on that, so I'm going to let you pull up your Z table and try to find it. Negative 0.08, and be careful, you're just in the hundredths aisle. It's zero, this is like 0.08 when you look it up. Okay, and what does that turn out to be? It looks like it is 0.4681. So really what we just found was this area below, all this right here, is 0.4681, just to show you what it looks like visually. So therefore, what is this side? What is all of this? It's 1 minus that 0.4681, which is equal to 0.5319. Or in other words, the probability that if a person is randomly selected, his weight will be greater than 175 pounds, that probability is equal to 0.5319, or approximately 53% chance. There's a 53% chance that could happen. That's a pretty high chance. So let's now take a look at using technology, because sometimes when we plug this value into our online homework, it'll give us an error, although it shouldn't, because we did use the z-table correctly. But it's worth going through that review. So what I'm going to do now is just open up StatCrunch, and here's our normal distribution calculator. Go under Stat, Normal Distribution Calculator, all in your StatCrunch notes. And the nice thing about this is we don't even have to find the z-score. We're just going to put the mean of the problem in, which was 177 pounds. We were told that the standard deviation was 26. And we don't even have to do 1 minus. We can do greater than. We're asked what's the probability that we randomly select someone who weighs more than 175 pounds. We'll compute that. And sure enough, it's 0.5307. You could round it. So so it's slightly off, a couple of thousandths of percent, or hundreds of percent, but either one should be correct on your calculator. If you're having trouble with your hand computations and it's getting it wrong, just confirm with the StatCrunch. You should be doing that anyway with every problem, so you learn how to use both the technology as well as understanding how to do it by hand. Okay, so let's now go to Part B. Okay, Part B says, what is the probability now that 10 randomly selected people will have a mean that is greater than 175? So I've lost my question here, but the main things have not changed. We still have a mean of 177 pounds with a standard deviation of 26. Okay. But now, instead of randomly picking an individual person, we're going to randomly pick a group of 10 out of many, many groups of 10, and we're going to weigh all those people and figure out their average mean weight. So their mean weight, the average weight of the group. Okay, so here we go. Making my template again. So X in this case is now mean weights, and we're talking about groups of 10. Okay, the mean is still 177 pounds. Okay, and that 177 pounds is a z-score of, the mean is a z-score of 0. So our template is all set. And now I'm going to go back over here, change my color, and now let's figure out what's the probability that we have a mean of, or what's the probability we're greater than 175? 175 is still below. This is where x equals 175. It's really exactly the same problem we just did. And we have to find all this area here. What is the probability that this group would have a mean weight of over 10? I mean, a mean weight of over 175 pounds, and there are 10 people in the group. Okay, so again, we're trying to find the probability that this x is now, the average weight of 10 people is greater than or equal to 175 pounds. That's going to be the same thing as the probability that z is greater than or equal to what? Okay, well, this time I can't use the same z-score. The mean stays the same, but remember, when we start taking bigger groups, more than just one person, we have to find a new standard deviation. And what is that new standard deviation? The new standard deviation, like we talked about in class, is the original standard deviation divided by the square root of n. So in this case, it is going to be our original standard deviation of 26 divided by, but now we're taking groups of 10, so we have to divide it through by the square root of 10. And when you do that on your calculator, you will come up with 8.22. 8.22 pounds is our new standard deviation, and that makes sense because it's smaller than the original standard deviation. As your groups get bigger, your standard deviation gets smaller. You're getting closer and closer into that mean. Okay? All right, now I still have to find that z-score. This was just the new standard deviation, so the rest of it plays out exactly the same. We've got to find that z-score. The z-score equals the x, which is 175 in this case, minus the mean of 177, divided by our new standard deviation of 8.22. That means z equals, if you go to your calculator, it's now going to equal negative 0.24. So it's farther away than our last time, right? Because our spread is less. So now the same value is actually farther out. So minus 0.24 is what goes here. Minus 0.24. So this is a z-score, not an area, not a percent. All right, because this is greater than, I don't like that, so I'm going to say this all equals to 1 minus p, would the probability that z would be less than or equal to negative 0.24. All right, so that's going to equal 1 minus, and now this we go look up on our z table. All right. If you're having trouble using the z-table, please go back and watch some of my earlier videos on how to use the z-table. Looks like it is 0.4052. So that's, again, this space here to the left of 175. So to find the other side of it, we subtract it from that 1. Doing that on our calculator, we get 0.5948. Okay, 0.5948. Or in other words, there's about a 59% chance that if we choose a group of 10 people, that they will in fact exceed a weight of 175. So I'm thinking in terms of that last question, you might want to work on your elevator a little bit so that it can actually have a higher weight, a higher mean weight, because there's a really good chance that if 10 people get on that elevator, they will exceed that maximum weight of whatever it was, 1,750. There's a 59% chance of exceeding it. So I wouldn't want to be getting on that elevator with a lot of people. Quickly, let's use the technology again to confirm our answer. You will see here the mean is going to stay at 177. However, our standard deviation is changing from 26 to 8.22. The rest of it, it's the same. We're still trying to find out that probability that X is greater than 175 pounds. We're just going to hit compute here, and now it's gone up. It's gone up from up to 5.5961. Okay, so it's a little bit off. So you can try plugging in both those values if you're not getting the right answer. All right, so go ahead and give that problem a try. I think you can do it.